Hello everyone, welcome back to Adrenaline Tutorial Platform. I am Adrenaline, the Bazooka Prophet, BSc, MSc, and PhD in chemistry. And today we're going to be taking our time to actually take a question for students that are writing JUPEB, IJMB exams, AP exam, SAT exam, or Cambridge A-level exams. And in this video, I'm going to be taking time to explain questions under this aspect. Now, on the board is a question that says, write the reaction rate expressions for the following reactions in terms of the disappearance of the reactants and appearance of the product. There are some keywords there we should actually take note of. Now, I did say in my previous video that reaction rates can be written in two ways. One, in terms of the disappearance of reactant, the word disappearance of reactant, which also means the consumption of reactant, and the product appearance or product formed. Now, the first one. In the second way of writing reaction rate is in terms of the rate constant, which we'll later do in our subsequent video on this series. Now, look at it and be relaxed while I give you the simple steps approach on how to get your answer with ease when it involves questions in exams. Now, let us address it. But before then, let me give you a sample of this question. For example, I'm giving A plus B, giving C plus. Now take note, A and B are the reactants. C and D are the product. You see these small letters, they act as the coefficient or as the mole ratio of the given reaction. Now, be very, very observant here. A and B are the coefficient. C and D are also coefficient, meaning A and B are the coefficient of the reactant. C and D are the coefficient of the product. Be calm and still to look at the procedure here. Now, if I have to write the rate of this reaction, what are the basic steps? The first step is you have to write the rate of the reaction of each of the components of this reaction. You have to write the rate of the reaction. Take note, rate is now equal to A. Whenever your reactants are consumed or they are disappearing, if they are disappearing, they take negative signs like negative. This coefficient here simply means 1 over the coefficient, which is 1 over A. Then the change in the concentration of A over change in time equal to, of course, B is also in the reactant, to take minus first. Then this coefficient here will become 1 over B, change in the concentration of B over change in T equal to, because C and D are formed or they are appearing, they take positive sign. So it becomes plus. Of course, this C here will become 1 over C, change in the concentration of C over change in T equal to plus 1 over D, change in the concentration of D over change in T. Now, if you understand how I explain this to you, then every other aspect of this question can be solved with ease. Now, we can now erase the board and do this A question now. Look at it thoroughly. Look at it again. Now, let's now solve this question. Now, in solving this question, now I come here. For A, of course, I've told you, the rate of the reaction is equal to, because ammonia is in the reactant, because ammonia and oxygen are in the reactant, so they will both start with negative sign. So, minus this 4 here, which is the coefficient, they become 1 over 4, change in the concentration of ammonia over change in T equal to minus 5 here will become 1 over 5. Change in the concentration of oxygen over change in T equal to nitrogen 2 oxide and water are formed. So they will take positive sign. Why their coefficient will become 1 over their coefficient. 1 over their coefficient. Don't forget that, please. Okay, so we can start. Now become plus 1 over 4. Change in the concentration of NO over change in T is equal to plus 1 over 6. Change in the concentration of H2O over change in the time. Remember, this is change in the concentration. Analytic concentration is in mole per dm cube or mole per liter. That is why the unit of the rate of the reaction is mole per liter per second. Now, if you actually do understand this is what you should do for me for B. Follow the same principle. And when you are done, you can drop the answer on the comment section below. And when I see it and you are correct, I get you a present. For now, God bless you.